Hello everybody, my name is Lucy and welcome to C2RS. In this series I'm going to be performing code translation from C to Rust. It's going to be focused on teaching, as the code I'm going to be translating is all of the code from my university's C programming language course. This will be the code that is written by me in order to complete the task set within the confines of this programming course. This first episode is going to focus on output, specifically output to the standard output, and the idiomatic ways to do that. However, this is not simply going to be about code translation, it's also going to be about learning to use both the libc reference manual and the Rust documentation. And we're going to talk a little bit about the differences between the languages, both from a concepts point of view and from their actual core design philosophy. So to kick things off, we're going to go into an editor, and we're going to start writing the C program. Now, to start, we're going to need an entry point into our program, as you will need for almost all non-interpreted languages. And in C's case, we do this by saying our return type, which will be an integer. This is the error code, essentially, that we give back when the program is run. We're going to need a name, which will be main. We need arguments, which in this case is void. We expect no arguments. And we need our code blocks. Finally, we need a return statement. Now, you may be looking at this and thinking that second void is superfluous, as is the return statement. And yeah, you're right. 99% of C compilers will add the void in for you and add the return statement in for you. However, I believe, and I would love to be corrected if I am wrong, but this is sort of the most correct way to write C as defined by the ISO standards, which I have not read, and I think it's ISO. It may be another one of those huge acronyms beginning with I, but I think it's them. I think this is how it's supposed to be done. If I'm wrong, please correct me, because I don't want to be teaching misinformation here. And if it is the case that I'm wrong, there will be a annotation somewhere. Anyway, disclaimers and me questioning myself aside, let's actually go ahead and run this program, which we will do by first compiling it. Fatal. Entry point must be defined. Interesting. Oh, I forgot to write. Okay, I've actually written the program, and now I forgot to save my work. And now we should be able to run hello.exe, and we see it does nothing. You will notice it actually inserts a new line. This is a thing with Windows. Windows will automatically add a new line after a program has run. Linux systems, and I believe Mac systems, so it's probably a Unix thing, will not do that, which creates an interesting situation where you will often want to add a new line to the end of any output you do in various programming languages, so that you can have that that compatibility with Linux and Mac OS X, even though for Windows cases it's not actually needed. So next of all, we're going to need to figure out how we get standard output. The basic task for this is just to write to the standard output the phrase hello world, which is a very common startup programming task. But the next place we have to go is somewhere very intimidating for a lot of people. The C Standard Library Reference Manual. Now, this document is gargantuan and impossible to navigate. It is 1,103 pages long. It's huge. But it's fine, because it's got a contents page. There we go, simple contents. What do we want? We could go to the input and output overview. Most programs need to do either input, reading data, or output, writing data, or most frequently both, in order to do anything useful. This section has a large, the GNU-C library provides a large selection of input and output functions, but the hardest part is often deciding which function is most appropriate. And this is something that is going to, I think I can demonstrate quite nicely by just asking a question. For those of you that use C, I want you to think for a second what function is correct to use in this case for writing a Hello World program. And a lot of people, and if you go on the internet, this is an issue I have with the most common way for people to find things out about C is not to go to the documentation because it's huge and scary, but is instead to Google things. And this leads to what many people will have just either thought or maybe said out loud if you feel like talking out loud in your own home, is printf. I'm going to say you're wrong, and we're going to find out why. So we can see input and output on streams. Well, it is in fact a stream that we're working with. In fact, it's the stdout stream, which is mentioned here. And there's lots of information about the stream, but what we actually care about is finding the function for output to a stream, for which I'm going to quickly go back to the contents for. This is the full contents. We want chapter 12. And we want simple output by characters or lines. And you will see there are these functions that have put in them. So here is fputc, which converts the character C to a type of an unsigned car and writes it to the stream. An end of file is returned if a write error occurred, otherwise the character C is returned. And there are a lot of these functions. And we'll notice that C here means car, so I'm probably looking for something that ends in an S, because string is the usual way to refer to a car star, which is a pointer to a list of cars, which is C's way of doing a string. And if we scroll down, we see put car, which is equivalent to put C, but it has a default of stdout. And here we have fputs, which takes a car star and a stream. However, there's probably one where the stdout is implied, just like there was a put car. And if we scroll down a bit further, we find puts. Puts function writes the string s to the stream stdout, followed by a new line. Note this is key. If we used printf, we would have to manually supply a new line. Here, it's done automatically for us. The terminating null character of the string is not written. Note that fputs does not write a new line, as this function does. So it's a more high utility fputs. Puts is the most convenient function for printing simple messages. So I think based on this description given in the C standard library, that puts is probably the correct thing. Now what defines puts? If we go up to the top of this section, we can see that these narrow stream functions are declared in the header file stdio.h. So let us head over to our code. We need to include, if I could spell, stdio.h, and we are going to puts hello world. Now the most common way you'll see this done on the internet will be the printf command, like that. I personally think that puts is more elegant and based on how it's described in the docs, should be considered the proper idiomatic way to do this. So I've written it. Let's go build it and run it. And you can see that it has performed the task correctly. So time to move over to Rust. I'm going to start by rust hello.rs. So let's start by writing the bog standard Rust unit function. Rust functions start with the keyword fn, followed by the function name, followed by any parameters. For Rust, there is no need to specify void. An empty set of parentheses will assume no parameters. And some curly braces that start our function. We could annotate our return type. However, unit, which is a empty tuple, open parentheses, close parentheses, is the default return type. So we don't need to specify anything there. And we also don't need to say return the tuple or do an implicit return by listing the tuple, as again, this is just implied. So this should be our unit function. And if we go on over to our code, we can rustc hello.rs and then run hello.exe, and you see we get just an empty line, nothing has happened, same as in the C code. We want to learn how to output something. Where are we going to go to do that? We're going to go to the docs. And you can see I'm already at the right place. Let me go back to where you will be when you first start out on the docs. You'll be on this page. There are 5 things in here. The Rust Programming Languages, which is the book. It is the most comprehensive resource for all topics related to Rust, and the primary official document of the language. There is the Rust reference, which is describes its working detail. It tends to be out of date. This has been known to be quite true in the past. And the standard library API reference. This is the most equivalent thing to the libc document I just showed you. However, I'm going to show you why it's a pretty bad idea to use it as a new user fairly shortly. The Rustonomicon, which is for advanced programmers, so we're going to pretend it doesn't exist, and a list of all the errors the Rust compiler can split out. So let's say we want to do an equivalent thing to what we did with C. Okay, there's no contents page, but maybe let's look for a list of sort of modules we can look in. And there's some types. Here's some modules. Okay, let's look for input and output. There's I/O. Shows some examples, but let's look for... Oh, here we go. Standard input and output. And you can see they use this thing called a print line. Now this is a macro. Macros, you will notice, are not listed here. This is because the macros are actually listed down here in the main page of the standard library. And the macro we care about is println. Now you might be thinking, that was pretty easy to find what we were after. Well, let me show you another path you could take looking for the docs. So we go to I/O and we scroll down to the bottom here, thinking, okay, well, let's look for types and functions. Well, there's the stdout type, which maybe we're going to need. And there seems to be this stdout function, which creates a handle to the standard output. So maybe we want to use that. Okay, so we just need to call that, and it's going to give us access to the standard output. Okay, and standard output has this lock method. What else has it got? It has a write method, where write allows you to write a buffer into this object, returning how many bytes were written, where it returns a result. Okay, well, the result is a type alias for this result, and this result has OK and error and some types, maybe some capital letters that are listed up here, and I don't really know what those do, and it all gets very scary very quickly. And also, what's this buffer nonsense? I just want to give it a string. Well, this buffer is sort of equivalent, but it's using a U8 instead of car, so it's raw bytes. You may end up writing some code that is not very elegant and looks something like this. stdout. Right. You may end up writing this code, and if we go to build this code, you're going to see that this, this does exactly what we want. Doesn't give off any errors, and we can build it. And it runs. But the amount of information we needed to gather just to write that code, we needed to understand that there was, if we go back to the code, we needed to sort of know that we needed to import write in order to use write, even though it seemed to be defined on stdout. We need to know about bytes to create a byte string instead of a regular string. It needs the new line at the end. It's got this unwrap thing, which we use to get rid of a warning about unused must use. You have to go down, which is related to that result type with its T and its E. You have to chase down this paper trail. And so it's very important to know that often The way you'll find to do things in the standard library reference is not the correct way to do things necessarily, because it is much more elegant for us simply to say print line hello world. And to demonstrate that this works, we will build it. There are some errors because I need to delete these. And run it. So, two ways we could have gone through the docs. One that gave us something incredibly ugly and I would argue non-rustic, and one that gave us something much more elegant. There's got to be a better way than risking this potluck. Well, if I bring us back to the Rust documentation, if we go into the book, which I'm going to zoom in a bit so it's a bit larger for you, if we go into Getting Started, we can see it gives us a lot of information about what Rust is, but then here we get how to write hello world, and here is the code sample. So for new learners of the language, the Rust book is a much more elegant way to find out what it is they want to do. And it also teaches you a lot more about the program on the way. It teaches you about this function definition the way I did, and it explains what this exclamation mark is, which is something I'm going to mention now. In Rust, exclamation mark means that the thing is a macro instead of a function, where macros are essentially much more powerful in that they can take an arbitrary number of arguments, they can write code for you that in a way that you would otherwise not want to do yourself, and in a way that wouldn't be possible in functions. They are highly useful. And if we look at the actual impact that this has on in terms of our code, if I were to go back into the standard library reference, look at the print line definition, you'll see for our case here, we're taking a single expression. Well, let's look at the source code. And we see for a single expression, we're printing, which is another macro, a concatenation of fmt, which is the expression we're passing in. Let's zoom in on the code. The expression we're passing in, and then a new line. Okay, well, let's look at the definition of concat, because that's got to be in here too. And concat is a built-in compiler, is a function built into the compiler. But essentially, it allows you to concatenate literals, as demonstrated at the bottom here, into a single string. Okay, well, what about print? What's that doing underneath? Well, if we go into the source, it is performing this IO print on some format args, where it's passing in all the arguments it received again. Well, what does format args do? Format args is compiler built in. So finally we've hit the end again, and we can just read what it says it does, and it produces a value of type fmt arguments. It takes in a bunch of format functions, and it allows you to basically format a string. So here we can see we're going to format the arguments hello and some curly braces followed by world, and then we're going to assert that, you know, it produces the arguments that do formatting. I think is the most eloquent way to say what it's doing. And then there was another thing, was there not, inside print? Yeah, we finally got this function. We got IO print. So let's go have a look at that. So we'll go into the IO module. And where is this underscore print? Well, doesn't appear to exist. So let's see if we can find it. There it is. Using self, the stdio module, and then there is this underscore print. Okay. So is there this stdio submodule? And you'll notice there are no documentations. There's no documentation for this. But if we search up here for underscore print, it doesn't find it. This is because the documentation for this has been hidden. Why? Because it's something you should probably never invoke yourself. Because we have abstractions over it in the form of print. which is much nicer to use. And the nicety of this is because Rust focuses on these things called zero-cost abstractions, even though there's this huge daisy chain we've just gone down, Rust's always going to take sort of its most minimal path through that, which means that for just this, it is directly equivalent to us just calling that underscore print method. And I believe if we were to chase down the documentation for that underscore print method, it's going to look pretty similar to that code we wrote where we built the stdout, unwrapped it, but without us needing to know about that huge daisy chain and all of the logic involved with that. I feel another coughing fit coming on, which I don't want to subject you to, and I'm also feeling that I've sort of said everything I wanted to say about writing Rust code today. So I'm going to draw this episode to a close. Thank you all for watching, and I hope to see you next time.